Hi, thank you for tuning in again. 2 weeks ago we went over the technical changes that we've made, and today we're going to talk about more technical issues and changes and rover configuration. We have the progress that we've done in 2 weeks. We have 3 different rover configuration. One that is our virtual rover at this point in time, and I'll explain to you why we're calling it virtual rover. We have the ground station, and then we have the compact version of our rover. And the last thing that we're going to talk about is the manufacturing process. So if you pan in over here and take a look at the screen, this is our virtual rover. It exists in 3D model format. Major parts have to be made from carbon fiber, and this is our carbon fiber right here. Right? What we're going to do is we're going to build the molds using this 3D printer, and the material that we're using here is PVA, it's just glue. So this is the mold that we're going to have, and we're going to put around the carbon fiber, and as the solidifying agent we're going to use epoxy for it, and it will act. So right now we're calling it a virtual one because we know that for the time that it takes to put all the carbon fiber parts together and all the proper molds, it will take 45 days. So right now it's virtual. The second configuration that we have, if you pan back here, this will be our ground station. We're actually waiting for the parts to come in, so next week we will be assembling it. We're not going to be using the carbon fiber parts because it'll be an expensive. It'll be too expensive, right, for our testing purposes right now. So we're gonna have this guy moving around on Earth. And our last configuration, this is the compact version of the rover. You see, this is our Helix antenna. And the purpose of this is we're going to be using this as a software debugger to see if our communication is properly flowing and we have no errors. One more thing to add about the compact rover and the ground station rover. If you take a look, this one, it has 4 stepper motors, and the compact version, it has only 2. The purpose of one of our goals is to make the proper software that could, because eventually we will be using this ground station to find the flying target, which is our CubeSat. And what we would like to do is build a software that could work for both configuration. So working for the 4 stepper motor and the 2. So now, we're going to talk about the manufacturing of the Helix antennas. This is our regular size Helix. This is what we're using for our communication. And then we also have a 3D printed smaller reduced size of antenna. The reduced size Helix has some major advantages. The 3D printing is twice less expensive than the regular Helix. Different winding of the conductors allows us to reduce the interference of 2 transmitters working on the same frequency at the same time, which is important in the case of a constellation of CubeSats flying together. And lastly, what we have done in this last week was we've integrated the electronics with mission control, and this electronics, we will be using it, it's the same electronics that we're using on our rover and our CubeSat. Now, the unique part about our mission control is that it's mobile. Well, it's on the web, but you could access it from anywhere in the world. And our ground stations, we can position that anywhere as well, because we've done our mission control through the web, through server. So if you take a look over here, if you remember, this is our mission control here, and this is what the server is getting. This is from the ground station. So what we've done here, if we go over here, and we're gonna send a command to a ground station, and we would want a reply from that ground station. So if we go back into our post, so this is the data that we've got from our ground station, which is in Vancouver. Let's send another one out. Let's make it length. So you see the difference. This is our ground station talking back with us, communicating, and the data is coming through. So thank you for tuning in, and we will see you next week, hopefully, with some exciting updates. Thank you.